Hello everyone, I've got a postbag video for you today, but not my normal AliExpress postbags. I've got a special one. Single item, and it's come all the way from Bulgaria, and it is labelled Rooaarrr, which I assume means priority. But a little hint of what it is this little logo, which is a dinosaur, or to be more precise, it is a Tinusaur. There's a label on the front as well, Tinusaur. Inside this box is a Atmel ATTiny85 development board, developed by some guys in Bulgaria, and it's basically a breakout board for the ATTiny85, just to get people into coding, get people into electronics and microcontrollers. Yeah, it just makes it easy to work with the chip and set up little projects and little demonstrations of how the chip works, and just to get people into electronics and microcontrollers. I got this kit. I backed a campaign on Indiegogo. The guys that developed this board, they've shipped it out before, but they set up a new campaign just to try and bring the overall cost of the unit down. So I backed that. I got an education starter pack. It's got a couple of extra add-on shields, and it's got a programming controller. But let's go take a look in the box and see what I've got. Okay, so here's the kit. Let's just get stuck in. That is the board. That is the box. This is what we get. Great big CR2032 battery. And this is the main Tinusaur board. So these are all the parts to go with that. We'll have a look at that. Just get everything out for now. Now this is one of the shields. This is the it's the Edu X4IO shield. I assume the 4IO stands for the 4 sensors that are on there. There's an LED, there's a switch, there's an LDR, and there's a buzzer, which you can all program and react to various inputs and actions on the ATTiny85. This is the other shield. It's got a label on it as well, but this is basically the LED X2, which is called for obvious reasons, because it is 2 LEDs and there's 2 current limiting resistors, so the LEDs don't burn out. What's this? This is the USB ASP programmer. So to program the ATTiny85, you can do it in various methods. You can use Arduino and hook it up, or you can use one of these USB programmers, and there's a header pins which go into the programming socket, which should be on the board. We have a reference diagram of the board, shows you where all the components go, and a sticker. I'm a Tinusaur Indiegogo supporter. Rooaarrr. And that is everything in the box. So this whole kit was the starter education kit, and with shipping I think it came to about $10. As mentioned before, this was all on a Indiegogo funding campaign for the developer to fund the sourcing of the parts and the production of the PCB. The author of the Tinusaur and the Indiegogo campaign goes by the name of Neven Boyanov. I hope I got that right. You can actually find he's got a YouTube channel that he's set up. I'll stick a card up there. You can go check that out. They haven't got too much content yet, but definitely worth a subscribe. Now this whole kit and the whole Tinusaur ethos is all about learning, teaching, experimenting and understanding. So you've got electronics, you've got soldering, you've got the microcontrollers, you've got coding and programming, and just understanding various geeky electronics microcontroller stuff. So with that ethos, everything is in kit form. You'll need to solder it yourself, and learning to solder, learning to understand the parts, following a circuit diagram, understanding where all the components go, and putting everything where they should be. Let's take a closer look at the Tinusaur and the shields. This is the main unit. This is a coin button battery cell, CR2032, standard 3-volt lithium cell, which will power the microcontroller and the LEDs and sensors. So this is the main board itself. The boards were produced by Oshpark, and in their traditional style it is a lovely purple and gold finish, and they do look rather good. They're a little cluttered, I have to say. I think the silk screening is quite cluttered and difficult to read, but everything is there. And interestingly, they developed this circuit on 123D circuits, which is an Autodesk circuit design tool. It's a free tool that you use online. Interesting. Here is the chip. You can just about read that. It is the Atmel ATTiny85 chip. It's got 8 legs, 6 pins, and a voltage in and ground. Really tiny, hence the name. You've got various components. You've got your programming header, the coin cell holder, various male, female header pins and jumpers, a resistor, which I believe will be for the reset, a pull up or pull down resistor, and a couple of capacitors, I assume to level out the power and keep everything stable. But that is it. That's all you get. There's not much to it. Actually, there's a reset pin. I'll not bother taking out the shield for the LED one. You can pretty much work out what's in there. You've got the shield itself, 2 LEDs, 2 resistors, and the male header pins, which will be soldered in. And the idea is these shields will go on top of the main board. So this is the Edu 4IO shield. It's got a buzzer, a switch, an LED, an LDR, light dependent resistor, a couple of normal resistors, and some male headers to plug everything in to the main board. This will be quite an interesting little board. You'll be able to get it to react, so you could change the light levels and an LED would light up or a buzzer would light up. Quite interesting, this one. So that is the Tinusaur board. Everything appears to be there. It's just a case now of soldering it up and plugging it in and getting programming on it. I'm going to do that on another video. I'll probably do a guide as well and stick that on my blog with some step-by-step instructions. Yeah, looking forward to this. I've got a few ATTiny boards, various DigiSparks, some LilyPad small ATTiny boards. But yeah, this is another one. Just have a play with this and see what it's like. One of the reasons for getting the Tinusaur was maybe to see if my daughter was interested in the electronics side. She's done a bit of coding with Scratch. She quite enjoys that, so I thought I'd get her to see if she enjoys the electronics side and setting up the projects, maybe come up with some ideas of her own using the shields, getting the LDR to light the buzzer, light the LED, or to make the buzzer sound. So yeah, we'll see if she gets interested in that. So thanks to Nevin Boyanov for the Tinusaur project. I'm sorry if I keep getting your name wrong. Again, now I've got the card in the top corner there. You can check out his YouTube channel, and don't forget to check out his blog if you're interested in getting one of these boards as well. And I will see you when I build the actual board itself. Thanks for watching, guys. Don't forget, if you enjoyed it, give it a thumbs up. Don't forget to subscribe and check that bell when you do subscribe so you'll get notified of all the upcoming videos that I will be doing. Cheers! Oh, and if you've been interested in knowing what this is that's been running in the background, this is one of my projects that I'm working on at the moment, and it is an ESP8266 notification thing that checks in with one of my Octoprint print servers for my 3D printers. I just wanted a way of just checking the progress of the printer because it's not in the same room that I'm normally in. And the Octoprint has a fantastic API that you can tap into, and as it's just done it, at the moment this is a progress bar and the NeoPixels are showing that I've got a print running and it is about 80-90% complete. So I know that when they're full, I just need to go check on my print and get it off the print bed. It's got a long way to go yet before I make it public or show any documents or the build process. It'll need a case and all sorts. I've got an OLED that I want to set up as well. Maybe get the temperature and the progress and the percentage. But yeah, it's on its way. So stay tuned for that as well. Rooaarrr.